So this question is an impact question but using vectors, which does seem to come up a few times in the past paper questions, but there isn't much examples of in the book. So we've got our particle falling down onto our slope. The slope of the plane is parallel to the vector negative 4I minus 3j, and its velocity before is negative 7j, and afterwards it's got velocity negative I plus j, and we've got to show that A equals 6. Now, to do this, you need to use a little kind of fact that you really just need to remember once you've convinced yourself it's true and you've worked it out, and that's when we're dealing with vectors. So say my velocity is given as a vector u. If I wanted to resolve that into directions, for example, let's have a right angled triangle here. So this side would be the modulus of u, if that was theta, cos theta, and this side would be the modulus of u, sine theta. Now, say what I want to do is I want to resolve parallel to a vector. Let me say, for example, I'll call that vector b. Then you also know with vectors that cos theta is, now I'm doing the angle between two vectors, that'll be u dot b modulus of u modulus of b. And you can combine those things, so that means that the component that is parallel to my vector b would be modulus of u times u dot b over modulus of u modulus of b. You can see that these two cancel out. So that leads us to the fact that if I want the component of a velocity called u parallel to another vector with direction b, vector b, then that component is u dot b over modulus of b. And any past mark schemes, they seem to expect you just to be able to use and put this, so you're not going to have to work it out every time. And that's how we do this question, which as you can see, the first part is only 2 marks. So, what are we using? We're using the fact that parallel to the plane, there's going to be no change in the component of velocity. So that means before, so what have we got before? Well, the component we've got before is going to be 1/5, because the modulus of negative 4I minus 3j is 5. So 1 over 5, and then the dot product of the initial velocity with the plane, and that has to be equal to, using this again, so the modulus of b is 5, 1/5 our final velocity, which is negative a1, dotted with the vector that the plane is parallel to. As we can then see, the fifths are going to cancel, so that's going to be 21 is 4a subtract 3, so 4a is going to be 24, so a equals 6, which is what they wanted us to show. Right, so once we've done that, in part B, they want us to find the coefficient of restitution between P and the plane. Okay? So, what we want to do now, we're going to look at perpendicular to the plane, and then we can use the impact law, with E being speed of separation over speed of approach. Right, so what do we need to do? Well, first of all, we need to find a vector which is perpendicular to the plane. And you might be able to do this in your head, but what I've got is the plane is parallel to negative 4I minus 3j. So the way to think about this is, if I want a perpendicular vector, which I'm going to call AB, or AI plus BJ, then -4, -3, dot product with AB must equal 0. So -4, -3b, 4a, that's 3b equals 0. And then all you've got to do is think of how can I solve that? Well, if a is 3 and b is -4, that solves this equation. So that's a perpendicular vector. So a perpendicular vector is 3, -4. And then I can just again use my key fact here in order to work out the two speeds. So E is going to be the component perpendicular to the plane. Again, this is going to have the same modulus, so it's going to be modulus of 5. So there's my perpendicular vector with my speed of separation, which is my final velocity, which was -6i plus j, over my speed of approach, which is going to be a fifth, so perpendicular vector, times the vector, which velocity vector for approach. And that actually, in this case, gives me -28 over -2 over 28, which gives me -1114. And at this point, there's a bit of a problem because E should be between 0 and 1. And I've got a negative number. Now, this is to do with when I found my perpendicular vector. Remember, with vectors, vectors have direction. So there is actually two ways, or infinite number of vectors that are perpendicular. I've actually found one that's ended up giving me a negative. It doesn't matter because also in the modulus here, the coefficient of restitution, I should have had speed, and speed is always positive. So what I need to make sure I do is I take the modulus, or the positive value of this, and then I will get that E is 11 over 14.